Yes, I'm tells about the uncle. He's suffering from asthma. He works in Delhi and due to high air pollution, he is unable to recover.
Oh no, I'm afraid about our health.
But how can we maintain good health?
We can maintain good health on our own by having a good diet, a good sleep schedule, and doing physical activities.
We can also maintain good mental health by positive thinking and emotional health by good social relationships.
What about the air we are breathing? It is not in our hand. It is the collective effort of the whole mankind.
Don't worry, Mansi. I have an idea. We can make a project to clean the air around us.
To make the world sustainable.
I, Veer Singh Base, Athar Malviya, and Ardhesh Mittal and Mansi Gaur are here to present our project, an AirPurify Nirmal. The theme of our project is based on science and technology for sustainable future, and sub-theme is health and hygiene. Now, Athar will explain the causes of air pollution.
Sure, we. Air pollution is the silent poison damaging our health with every breath we take. Air pollution is a critical global health concern, causing approximately 7 million deaths every year. The major causes of air pollution are the industrial emissions, burning of fossil fuels, wildfires, transportation, and open burning of garbage waste. All these factors increase the CO2 levels and fine particulate matter in the air.
Oh, garbage waste is well maintained in a city indoors without burning it, and therefore 7 times as the cleanest city. I am sure we can put efforts to purify air as well. Our idea specially focusing to decrease CO2 from the air.
Let me highlight the impact of CO2 in the air. Though CO2 is necessary for life, but excess of it can be harmful. Generally, 400 to 1000 ppm of CO2 level is considered safe. However, concentration closer to 1000 ppm often found indoors in poorly ventilated spaces. It can lead to mild cognitive impairment, fatigue, and reduced productivity. Above 1000 ppm of CO2 can lead to headache, drowsiness, dizziness, and even shortness of breath. Above 5000 ppm of CO2 can lead to respiratory problems, unconsciousness, and even death in extreme cases.
Oh, but what technology are we using in our air purifier?
By using AI-based smart technology, tools such as smart scheduling, AI-based smart sensors, smart dispensary systems, UVC disinfectors, aerial cleaning, and performance metrics, cleaning becomes more efficient.
The main features of our project are real-time CO2 monitoring, CO2 absorption activation, UVC air purification, continuous air circulation, battery management system, and portable and autonomous operation. Now moving on to the components of our project, which are battery, Arduino Uno, CO2 sensor, UVC light, fan, pump, relay module, and jumper wires.
Let me explain you the working of our prototype. So here we have 4 intake fans which take in the polluted air from the surrounding, and 1 exhaust fan which release the purified air into the surrounding. The entire system is managed by the Arduino Uno, which is a microcontroller. See, here we have HEPA filter papers which would be covering these fans. Now air will pass through it, and these HEPA filters will remove the pollutants from the air as small as 0.3 microns. After that, the air will go through the UV lights inside, which will kill the RNA and the DNA of the germs present inside the air. The entire system has a CO2 sensor. This CO2 sensor continuously monitors the CO2 level of the surrounding and sends this data to the Arduino Uno. The Arduino displays this data on the display, and if the CO2 level goes above the set limit, the preset limit we have in the code, then the KOH dispenser gets activated. KOH, that is potassium hydroxide, absorbs the CO2 and produces potassium carbonate and water as the byproduct, which is stored right behind here. And Finally, this purified air now goes through the exhaust fan and gets released into the surrounding. So this is the code we have used in our project. Now let me show you a demonstration of our project. So here we are taking acetic acid and sodium carbonate. This reaction will produce carbon dioxide as the byproduct, and I'm going to show it. Let's see. So here you can see the CO2 level is being raised. It was 400 earlier and now it's over 750. Now the KOH dispenser has activated. You can see the text right here, activating pump for CO2 level. The CO2 dispenser has dispensed KOH and the process of absorption of CO2 has begun. Now after it would take few minutes to get reduced and the CO2 would get absorbed. Meanwhile, we continue to our presentation.
Now moving on to the efficiency of the system, for every 44 gram of CO2 absorbed, the 112 gram of KOH would be consumed. For CO2 concentration at 1000 ppm, the amount of KOH absorbed will be estimated on the basis of CO2 concentration and air volume. Here are some statistics. If CO2 in 1 cubic meter is 1000 ppm, this equates to 1 gram of CO2. To absorb every 1 gram of CO2, the amount of KOH needed would be approximately 2.5 gram of 2.5 gram. For absorbing CO2, KOH is only released when CO2 is excessively in the air. Our project is very advantageous in such a manner that the byproduct of our project, potassium carbonate, has many applications in our daily life, such as household and industrial cleaning, water softening, agriculture and gardening, personal care products, glass and ceramics production, laboratory and industrial uses. Now, normal air purifiers use disposable air filters that require a frequent replacement, contributing to environmental wastage. By using paper-made HEPA filters, we make our models sustainable. Unlike traditional air purifiers, our model also decreases CO2 concentration and as well as allergens and particles removal.
Our project is feasible and cost effective. With modifications like high quality sensors and large fans, this could become an effective solution for public areas and high traffic places like metro stations, malls and airports. By linking with IoT and smart city technologies, this project could manage and control CO2 citywide. By integrating with solar and wind energy to run the direct air capture units, it can become more sustainable. In conclusion, our air purifier empowers individuals to prioritize their well-being and breathe easy, fostering a positive impact on both mental and physical health. This demonstrates an innovative solution to enhance air quality and contribute to a sustainable future.
From cars and factories, toxins rise. Nirmal brings fresh air back to skies. Thank you.
So here you can see that the CO2 level is below. At previously
It was earlier above 700 and 700 ppm, and now you can see it's around 400 ppm.
My question is, as you told, your model is cost effective. Okay. On which basis you say that your model is cost effective?
Sir, actually we have used Arduino Uno and sensors and KOH that is really cost effective, and normal air purifiers which are, I think, and I have researched, and it is about 30 to 40,000.
You calculated the cost?
Yes, sir.
What will be the cost?
Sir, it is about 4 to 5,000.
4 to 5,000 for a single model.
For
sir,
this one.
For this one. But
That is a single model.
yes, ma'am.
Okay. As according to you, your device purifies the air.
Yes, sir.
बट करेंटली जो रेगुलर ऑक्सीजन CO2 है वो कम होता जा रहा है. आप देखोगे आपने फंक्शनिंग का भी कुछ नहीं करवाया है. तो जो आपने CO2 को एमिट करवाया है वो कैलकुलेट करवाया है. ओके, व्हाट फॉर्मूला यू कैलकुलेटेड फॉर द सराउंडिंग CO2 एंड योर आउट CO2 में जब CO2 बाहर आ रहा है तब क्या फॉर्मूला लगा है डिवाइस में? क्या उसका कोई ग्राफ चार्ट बनाया है आपने कैलकुलेट करने के लिए कि एयर प्यूरिफाइड है? यू नीड टू सेटिस्फाई योर कस्टमर, यू नीड टू सेटिस्फाई योर ऑडियंस.
Yes,
तो
sir.
फिर कोई ऐसा ग्राफ या कोई चार्ट, कोई कंपैरिजन चार्ट बनाया है पहले और आखिरी में CO2 का?
Sir, when we will implement it on large scale, we can do that also. But it is
प्रोटोटाइप में होगा तो ही तो लार्ज स्केल में इम्प्लीमेंट करोगे. अगर प्रोटोटाइप में नहीं होगा तो कोई कंपनी लार्ज स्केल में आपको इम्प्लीमेंट ही क्यों करने देगी?
Sir, we have
जैसे आप देख रहे हो
tested it.
400 से वो नीचे जा रहा है. You catches CO2, it's okay. But how you purify that?
Sir, it will become stable after some time. As the current CO2 level is here, this is only that 364.5.
And it's okay. Do you have any research data?
So we have tested it. So we actually put a sensor when we were testing right here. So it made the CO2 level around 200 to 300 ppm. We don't have any recorded charts right now, but we have tested it.
Okay. Now the question from audience.
Sir, one more.
The question from Unique ID SBV 12CS, Sarthak Jain. What's the language is used in this code?
Sir, that is C or C++ as we have developed the code in Arduino IDE.
Okay,
Okay.
thank you.
Thank you, sir.
Thank you, sir.